good to go, Sergey.
Yeah, but people are still coming in, so let's maybe have 1 more minute to try to sit them down.
For those joining us through the stream, I hope that you will be able to see the room. People are still coming into and trying to find a seat.
Yeah, now let's start. Yeah, finally. So please have a big welcome. Almiray will talk about microservices with the data context. That's probably one of the hottest topics with all regarding microservices. You're welcome.
Thank you very much, Sergey. And I'm very, very glad to be here once again with all of you folks here at Stockholm, and for those joining us at their homes through the stream. And so the topic of today is microservices, and that's kind of like one of the hot topics that most people are debating. Should we go into it? Should we have not gone into it? Should we go back to monoliths? So the pendulum comes and goes, right? The idea of today is to showcase some of those popular microservices frameworks that you may have already seen or heard about, or maybe using. You may be considering perhaps switching, or you may be considering like, well, maybe the other one performs in a different way or in a better way. Now, there are many aspects that we can talk about microservices. There are many kinds of integrations that there are there. And today, I would like to talk specifically how we deal with data. So if you were looking for something about monitoring and observability, this is not it. But that's still an important part of what you do if you're working with microservices. Feel free to stop me at any time if you have any questions. I'll do my best to answer as soon as possible. If not, we'll still have time at the end of the session for any questions that you may have. And I know that in the end of the session, we have lunchtime, so I'll be competing against your hunger. I know that. So I won't take so much time at the end so that you guys can go and have some hearty lunch. So my name is Almiray. I currently work at Oracle. I work at the database group, and I have extensive knowledge and experience in the Java space. That's the reason why I'm here. I do care about Java. I write a lot of Java code, and I write a lot of open source code. So some people, when they hear Oracle and open source, they think those things don't mix. They are like water and oil. But actually, we produce a lot. So one of the things that we're going to see today are kind of like related to that particular area. There are other things that I like to do. I like dynamic languages. I am a member of the Groovy development team. I created an organization back in Switzerland called Hackergarten that allows people like yourselves to find other peers and work on open source projects. So, without any further ado, where are we in terms of software development? So, 2 years ago, or around 2 years ago, there was a survey conducted by JBrains. So you can find many developer surveys like the ones from Stack Overflow and other well-known and respected tech companies. But in the case of JetBrains, the important bit about this one is that they interview, if I remember correctly, it was more or close to 32,000 developers around the world. So the footprint of this particular survey is quite significant. So when they ask many different questions, but one of them was, how do you approach the design for your application? Are you still doing monoliths? Or are you doing microservices? Are you doing SOA? Does anyone remembers using SOA and XML and SOAP, and we still have those tragic memories and traumatic experiences? Well, it turns out that now, most people said we're doing some sort of microservices. And microservices is kind of like an umbrella topic, whether you're actually doing things that are really tiny, just one responsibility and connecting each other, or something that seems to be a little bit tiny, and just because you're using one of those frameworks that said, we allow you to build microservices, whatever it is, there's something going around. And then communicating these particular elements, these components in a microservices framework, the most common way to do it is using REST APIs. for which there's also a little bit of an umbrella. So REST is not just doing get or post. So there's more to it. There's meaning to the verbs. If you're just doing get, what you're doing is just a getful API. It's not a RESTful API. But in any case, as long as we're using HTTP verbs and some sort of format to communicate data, whether it's JSON or XML or something else, yeah, that kind of pass like REST most days. So most people are doing that, as we can see on those percentages. That's quite high. Okay, so when asked the question, which web framework or which microservices framework you use this, well, the reality is that a Spring framework and a Spring Boot or Spring-based technologies continue to be the dominant player in the market. There's always, they have been from 60% or a little bit above. Depending on who you ask, it will be perhaps all the way to 70s or 75. So here in this list, we see a Spring Boot, a Spring MVC, Grails, at least version 2 and 3 were based on a Spring. And Micronaut is there, and Micronaut has a compatibility layer so that you can use Spring components with your Micronaut application. And a similar bit with Quarkus. So you see Spring continues to be somewhere there. All right. So what alternatives do you use when running as an application server? Because one thing is that in the old days, we just package a big monolith, a big binary in a WAR file, and then ship it to an application server. Nowadays, we tend to write smaller applications in self-contained jars that have all the dependencies and have an embedded server. So which embedded server do we go, or should we choose? So again, Spring Boot continues to be the dominant player. We still have Netty, which I believe is the, correct me if I'm wrong, is the default choice for Micronaut to go with Netty. But if you want to, you can also use Tomcat, which is quite popular as well. So now we're talking about the data. For data, we have so many different options. But by far, the most popular database option that people go to is MySQL. Well, MySQL has been with us for a long, long time. You probably have been aware of what is known as the LAMP stack, Linux, Apache, HTTP server, M for MySQL, and P could have been Perl, PHP, or Python. Quite popular before the turn of the, no, actually in the first decade of this millennium. And Postgres is another option. And we also have NoSQL databases. Perhaps the most well-known or most well-used is MongoDB. When talking about which SQL or relational specific databases, again, no surprise, MySQL is still there, and Postgres is a close second. Now, you might remember I said I work for Oracle, so it's a good thing that MySQL is there, but also there's Oracle. And now there's one thing that I will say in just a moment about that, because we know Oracle is an scalable database, but not everyone wants to use Oracle for reasons. I would like to dispel some of those reasons and I'll give you some ideas why it might be a good idea to give it a try. But today we're going to see 3 different microservice frameworks, the most popular ones, so Spring Boot, Micronaut, and Quarkus. And it's not my interest to pitch one another and say, oh, this one is better because X, and this one does better because Y. More like what I would like to explore are some of the options on how one particular framework does one thing, and that may be to your liking. Or maybe it's the other framework that does things in a different way, and that you will probably resonate better with that one. In the end, from my point of view, I will never say this framework is better than the other in an absolute way, because it all depends. It depends on your SLAs, it depends on your customers, it depends on your requirements. So at the bottom line, what I will propose to you is that you select one framework, do a POC, and then measure. And then go again and do another selection, whichever it may be, do a POC, and do another set of measurements. In the end, with your own data, with your own requirements, with your own customers, you will be able to come up with a solution that is custom tailored to you. Whether that's a Springboard, Micronaut, or Quarkus, one of them will give you the benefits that you're looking for. In terms of data, well, we have many ways to access data, and there are many different ways to format said data inside the storage. Most common one, or the most popular one in the previous years, has been relational, for which we typically use SQL. As a Java developer, I don't like to deal with SQL that often. It's perhaps too low level. It's kind of like when we're writing frontends, any frontend developers in the house who writes HTML directly by hand. Not that many, or at least we used to, right? So it's the same deal with SQL. Once we have higher level libraries that allow us to write that SQL statements and connect to the database, we just forget about those things. For some people, SQL becomes like assembler. No one writes assembler these days. But the alternative then is NoSQL. If you don't want to use a structured query language, then you use something else, which is not just the format of the data, but the way that you access said data. So regardless if you go with the traditional relational or NoSQL, you still have choices. You may use one format, you may use one syntax, you may have to choose a library that allows you to process the format and the syntax and the data easiest way or faster, and that will lead to, should I change my build tool? Should I change my build process? So it's easy to say, yeah, NoSQL perhaps is more popular. Well, what does that entail? How much do I need to change the way that I develop if I were to choose a different format for my data? So there are many different vendors out there. You can choose from many different places with different formats. I just want to say that if you were not aware of, Oracle is not the only vendor that does it. But if you have an application that needs to talk SQL, relational, and NoSQL, column-based, key value, whatever it is that is in NoSQL, instead of having different engines and different vendors with different applications whatsoever and trying to come up with how to collect all that data and having some sort of common ground across all these things, you can have everything coming from one vendor. In this case specifically, the Oracle database allows you to have all these kinds of different formats under the same engine. And because of this, you can query all these disparate formats using the same language. I'm not talking about Java, which is obviously you can do so. I'm saying you can use SQL. You can use SQL projections over JSON data across relational, as if the JSON data was relational. Or maybe is there some other format? Again, Oracle is not the only one that does it, but there are interesting reasons why would you like to go with this option. Besides this, it's not just how the data looks like and how it's stored, it's when and how you're going to query it. Am I going to query it in a synchronous way? That is, the component that is requesting the data, is it going to wait until it gets all the data and then pass it on to the next component? Or are you going to make it asynchronous? In the recent years, we have been hearing about asynchronous frameworks. You probably have heard about reactive streams, Project Reactor, RxJava. There are many ways that we can use these libraries, especially when you're talking about business logic. And you can go all the way to the client layer. You can have reactive clients. Yet, when you go down to the deepest level, which is the data layer, the JDBC API that we know and that we use, and most of us use, turns out to be synchronous. So everything that we did on the upper layers to make things asynchronous, to be sure that we can reuse resources in a better way, goes to waste because the database will block us. That thing is still synchronous. Is there a way to access relational data in an asynchronous way? Is there a way for us to be able to be sure that we can reuse those resources in a much efficient way? Turns out there is. So then again, here's a choice for you. Is my microservice fast enough, small enough that if I access data in a synchronous way, is that sufficient? Does that comply with my SLAs? Or should I turn to some other alternative? So today I'm going to show two of those alternatives. So yes, everybody knows JDBC, and on top of JDBC we have JPA, for which there are a handful of implementations. You may go with Hibernate, quite popular, or you may do Eclipse Link, or you may do something else. There is another completely separate specification, which is not part of what is known as Enterprise Java, whether it's Java EE or Jakarta EE. This is known as R2dbc. And this particular specification follows the ideas of reactive streams. So if you know already RxJava, or Project Reactor, or the other implementations of reactive streams, then accessing data in a reactive way should be pretty straightforward. So here's how it looks like. That's the URL for the project R2dbc IO, which, by the way, if I'm not mistaken, the last week of April 22, so last week from today, they released version 1.0 of the specification, which is good. But most of the consumers that we're going to see today, they do not yet use that particular version. For example, Springboard, its support for R2dbc, which is version 1.4.4, still relies on version 0.86 or R2dbc. Turns out, R2dbc broke binary compatibility in version 9. So if you want to be sure that you're using the latest and greatest versions of all your dependencies because of security concerns or what have you, be aware that you cannot use the latest R2dbc with the latest Springboard yet. Similar goes with Micronaut. I believe they are up to version 0.86. They're not yet to 0.9. And some of the R2dbc drivers will also be different. Specifically for Oracle, they use version 0.9 of the drivers. So can we make use of all these things together in the same application? Yes. Just be mindful of the versions that we have to use. So like this is how you will access data in a reactive way. Some of what we see in this screen is similar to what you would do with JDBC, but notice that we're using those names and constructs from RxJava or from reactive. In this case, this is Project Reactor. So we're seeing a mono object that returns just one element whenever it's ready, and we're using that mono to connect to the database. And instead of just saying, okay, we're done with the connection, we continue chaining method calls into that string of values. So assuming we have a connection, the next thing we're going to do is issue a query, bind some values with kind of like using a prepare statement, and then execute this thing. But hold on, at that point in time, the execution may not yet happen, right? The idea is that this statement runs in a scheduler. It will run whenever it's ready. And once we have those values, we have to map from each one of those results or rows into whatever our application requires. In this case, we have a mapper in the third to last row that says, I'm just going to grab a value as a string. But this is very low level. Perhaps you want to use some actual object mapper, maybe it's mapstruct, maybe Lombok, maybe you want to use seal classes, maybe you want to use Kotlin or something else. Whatever it is, it can go exactly right there. And the last statement is the important one, because the only thing that we have done here, this is a recipe. This is what we want the application at some point to do. But we have not tell it, now do it. So when you say subscribe, is where that string of values will start to do its work. And whenever that thing is ready, we don't know exactly when, but when those values start to flow to the stream, then the mapper will be executed. So like this, if your data layer works in that asynchronous way, you can think of, well, now I have a mono object, or I have a flowable, or a flux, or observable, whatever this thing is, this reactive object. Then you can pass that container, this reactive object, through the different layers. You can go to the business layer and continue to do reactive. And if your client happens to be reactive, then you can continue pushing those values up to the topmost layer. And then just things will be connected. Questions so far? Going so good? Right. So in case of R2dbc, they support these databases at the moment. So Google Cloud Spanner, H2, which most people use for testing, MariaDB or MySQL, Postgres, obviously, SQL Server, and Oracle. So most of the major options that you will typically go for. Alternatives to R2dbc will be Vertex. You might have heard of Vertex for many years ago. Also, another framework that allows you to build applications in a reactive way based on Netty. They do have reactive clients for data access as well. And so they started with DB2, obviously, because kind of like is sponsored by IBM, but MySQL for obvious choices, and Postgres, SQL Server, Mongo, which is NoSQL, Redis, Cassandra, also NoSQL. And they recently added support for Oracle. They mark it as a tick preview in version 4.2 of Vertex, which came out late last year, if I'm not mistaken. It's quite solid right now, but just in case, if you happen to give it a try and you happen to find something that is not working properly for any of these options, please file a ticket. That's how you can help us, the producers of all these different technologies. Okay, so coming back to Spring Boot. There are many ways that you can use synchronous APIs to access the database. Who here still uses JDBC template? One of the earliest ways. My people. Okay, guess Hibernate, JPA are still out there. Who uses Spring Data, perhaps the most popular option? Not that much? Okay. I thought it would be popular. As a matter of fact, MyBodies, which used to be known as Apache iBodies, is quite popular in Asian countries. And obviously, R2dbc. So I'm not going to show all of those, because then I will spend like 4 hours, and you guys would like to have some lunch. So I'm going to show a demo, and actually it's going to be 6 different demos. The idea is to show how easy it is to get started with each one of these different options. The idea is not to showcase a full-blown application, so don't worry, this is not going to be pet cleaned Redux, because there's a lot of information. This is just straight to the point. This is how you do things. Now, based on that, of course, it's going to be a little bit of a trivial example, but I hope that you can get the idea of how you can grow this up. Okay, so right here I have my trusted IDE and have a Spring application, which is right now defined using Maven. The easiest way that you can bootstrap a Springboard application, there's a website called startspring.io. Just select the things that you want to, click a button, you get a zip file, open up in your IDE, start coding. There are other options. I believe there's a command line tool as well where you can do these things. So that's exactly what I did. I browsed the UI, I selected what I wanted, and I got this application. So 2 things of note. You're still using Java 11. Who's using Java 17 already in production? Okay, good hands, great. So I hope that the next year that I ask the questions, there will be more people using 17. So for now, I'm using 11, which is okay. I'm also using the latest version of the Oracle database. This value is managed by Springboard. When I do this, the Springboard will automatically configure every other dependency that this thing requires. So either you do this, or you do explicitly define every dependency that is required. In my case, I had to be sure that the JDBC driver, for which there are 2 versions, OJDBC 8 and OJDBC 11, I'm using 11 because Java 11. And if you want to optionally use the Oracle Universal Connection Pool, then define it here. Or you can use Hikari or any other connection pool. It works the same. Okay. Funny bit, I'm using a Mac, right? If you are aware where Oracle runs, it does not run on this hardware. But I'm going to talk to an Oracle database. How am I going to do that? I'm going to use Docker. In case that you didn't know, there are images, official images for Oracle databases, all products that run on Docker. There is one specific which is known as Oracle XC. This is the smallest one and is the free one, and there are no restrictions with the license. You can use it for testing, you can use it for development, you can use it for production. And you don't have to pay a dime for it. You just have to use it if you want to. Of course, if you reach this thing is limited at some point, so it's not it's the full product, but it just grows up to a certain amount of data. If you require more data, you require more access, more scalability, then just engage with someone that can give you a license. So, with this thing, we can set it up in production, we can set it on testing, we can use test containers if you want to. It's so easy to just get started. Just Docker image, off you go. That's exactly what I have here. So I have a Docker, a database running on Docker, so that's good. So let me show you the application. Very trivial application. What are we doing? Because I'm using the JDC template, it's very low level API, right? So some of you will use APA or Spring Data to manage the schema and seed the data with the database, seed the database with the data. So I'm going one step before that. So this is what I'm doing. I'm creating the schema, then inserting some basic data. If you have not seen Spring JDC template before, this is how you use it. Per statement and some array of data. And then we just query. And what we're doing in that query, we're doing our own mapping. To what? To a Pojo object. There is getters, setters, done. You want to use Kotlin, seal class, Lombok, or something else, mapstruct? You can do it. I decided to go with just plain objects. So that's the only thing that it does. What else can we tell about this application? Well, here's how we connect to it. Just define the particular URL so you can tell that that's definitely a database that is running locally on my machine. I don't care about the username password because there's no way you can hack that because it's running on my Docker instance, and once I close this application, this laptop is gone, okay? And some basic data about that, and that's it. That's all that I need. So without any further ado, what I do here is run it. Just launch this application, right? Click here, and they say run demo application. And we expect 2 elements to be added to the database. That's what the batch update is doing. And then query all those elements again. And that's what we get here. So trivial, but it works. That's what we expect. We want our microservices to be as, hopefully, as simple as this. One responsibility, nothing else. Okay. You can grow this to as big as you want to. You can do whatever you want with JDBC. So let's go into the next one. Let's go with the R2dbc Demo. So in this case, we're now, I believe, we do make use of a Spring Data. So here we go at the top. Now we're using a Spring Data R2dbc. We still ask a Springboard to manage the Oracle driver version for us. And what else do we have here? There's the JDC driver, and there's this R2dbc additional extension. And as I said earlier, be very mindful about this number. Latest version is 0.40, which relies on version 0.90 of the R2dbc specification. If I change this to something else, the application will break. I cannot use the latest version. And it's not because the Oracle version is too new, but also because the current release of Spring Data R2dbc has not yet upgraded. But I've been told that in 2 weeks, they're going to release version 1.5, which will upgrade to version 0.9 of the spec. Remember, R2dbc was just released last week, 1.0, so all those integrators are not yet ready to go with the latest and greatest versions. It will take a couple of weeks, hopefully, if not a couple of months, so that we get ready. How do things look like? I will consume data using the same POJO. Same deal. Nothing has changed here. Because we're using Spring Data, we will rely on the repository pattern or the DEO pattern. So instead of using a standard CRUD repository, as you would do with JPA or the synchronous way, we're using a reactive CRUD repository, which will give us access to the basic accessors of the data. So the list all, find all, get by ID, and get by or find by the names of the properties very, very easily. But because it's reactive, what we get as a result is not a collection of the domain object or the domain object itself, is a reactive container of the data that we want. So if we want multiple values, we supply a flux or a flowable. If we want a single value, it will be a mono or a single, right? So in this case, I guess the to-do object has a description property, so we're going to add explicit finder for a description. We may have more than one to-do object with the same description. The description is not unique. So that's why the return type will be potentially multiple values. That's why we have a flux, not a mono. And the query is just like any other query that you would do. Other than that, other than the fact that this is a flux, there is no other indication differently for what you previously would do with regular Spring Data. Finally, the application. I'm going to fake a few things. And by fake, I mean I know that I'm supposed to be using the API in an asynchronous way. But you will see here, I'm blocking. Because this is a trivial CLI application, and I want to demonstrate how to seed data and how to query data. This client is not reactive, it's blocking. Don't do this in production, please. So what we're doing here is invoking that save all method from the repository. This is the advantage of using Spring Data. We don't have to write those methods. It will just happen automatically by the framework. So we supply a list of values, and this thing will know when it will connect to the database. It will just flow the values through it, do a subscription, and then push the values. If the subscription were to fail, you could at some point also, I believe, where's the data? Here. We have this do on next method. This is a reactive method. I believe we have something like an do on error. In case that one of those insertions fail, then we can react to that. We have a consumer, we have a predicate. We have many different ways that we can do this. So we expect that after this, data is in the database. Then we find all of them and print them. Again, we're blocking. So it looks a little bit like JDBC. Then we find one by a single ID, and notice that now in this case we do on next, because these are regular reactive string methods. You can chain them all the way to the reactive client. You can supply this value will be I think what this thing is a mono. So pass this mono, whoever wants to consume a mono or may be able to consume a mono. And here we're using our finder. It's a find by description that returns a flux, and we do again use of those Rx or reactive methods. So that's everything that this thing is doing. The rest of the code is just making sure that we read the DDL code that is here so that we can create or initialize the schema. So when I run this application, let's do this, run, I will expect to see some printouts, and we can make this thing a little bit bigger. And here we go. So we injected data into the database, and then we query all of them, query one by ID, and query one by description. And we got all the data back. All right, any questions so far on Rx? Good to go. Now let's turn into Micronaut. So here we have, anybody here using Micronaut? A few hands. So with Micronaut, well, you have other choices. Well, with every other framework, you have the choice whether I want to build with Maven or Gradle. Micronaut has a preference to use Gradle, I will going to show Maven because I suppose that most of you are familiar with Maven. So here we are. Just like the other frameworks, you go into the web page of Micronaut, so micronaut.io/launch. You can configure how you want your application to be created, then just click one button and you download the zip and stop coding. Or you can also do this with the command line tool. Whichever way, you end up with a project. We're using the latest version of Micronaut, 3.4.3 as of now, as of today. And what else can we see here? We're still using version JDK, we're using Java 11 for this project. Latest versions of Micronaut and Micronaut data. So Micronaut has its own API, which is inspired by its previous, or well, how can I tell it? It's inspired of its DNA. You find Grails, and in Grails we have this API called GORM, which is the one that allows you to have these magical finders. Turns out, if I'm not mistaken, Spring Data took inspiration on this. So there is a lot of knowledge coming down the line, and Micronaut makes sure to reuse all that knowledge and push it to the next level. So that is Micronaut data. In this case, 3.3.0 is the latest release. So we have a bunch of dependencies. Micronaut, as opposed to a Springboard, prefers to use dependency injection at compile time. So that means that at runtime, your applications are faster and you use less reflection. If that is something that is ailing you in your applications, perhaps Micronaut will give you the solution that you're seeking. Okay, so more stuff that we see here. At some point, we should see the drivers. Here we are. I'm using the explicit versions, and one thing that you have to be sure, whenever you're using Oracle and you're using UCP, that these two versions must match. If you use different versions, things will probably don't work. So be sure to use the same version. And the rest is just standard Maven configuration for Micronaut. So there's no point looking at that, just look at the dependencies. As I said, Micronaut data looks like GORM and Spring Data. So that means we have a domain object with annotations. So getters and setters, a plain Java object, very simple domain class. And we use also the repository pattern. So here we have a CRUD repository. And we have an explicit finder. And because this is synchronous, we return a domain object as is. For this particular version of the application, you expect descriptions to be unique, so we expect just one item. Another alternative will be to turn this into a list or a collection if we expect more than one value. For now, we just do this. So what the application looks like? Very, very simple. Because Micronaut and Spring Data do a lot of the heavy lifting for us. So who is going to initialize the database and the schema? Micronaut will do it. How we'll know how the tables should look like? Well, it's based on all the domain objects that are discovered in your application. You want to use a different name for the table or a different name for the columns, then just supply that information through annotations. Otherwise, it will be just the code that you see in the source code. Sorry. So what we expect here is, at this point in time, the database is up, the schema has been set up correctly, we're going to fill the data where we pass two elements, and then we're just going to find everything. And because it's a synchronous application, this should just work immediately as is. So when we run this app, in just a second, here we go. Did I click run correctly? There we go. And make it a bit bigger. There we are. Application starts up, uses Hibernate by default, and we get the two elements inserted in the database. We were able to successfully find it. Right. It's as simple as that. I know it looks very, very easy because the CRUD repository gave us the save and the file of methods. We also have find by ID and find by the other things. So there's not much that you would do here. If you find more code in a repository class like this or an interface like this, it's because you want to use a very custom query or you're using a native query of some kind. You're using a lot of arguments perhaps, or you're invoking a stored procedure in a way So if you're doing that, that's perfect. But if you stick to the defaults or the conventions, then your repository classes will be very, very thin. Now, let me show you the reactive way. Here we go. Like the previous example, we're using Maven. And what is the difference here? Is that we should be using R2dbc. So here's the first thing, the first difference is here. We're using data R2dbc. And then the R2dbc core as well. And finally, there's the Oracle driver, of course, UCP, and that version of Oracle R2dbc, which again, if you try to use a hacker version of Oracle right now, of Oracle R2dbc, you won't be able to use it. So just wait until the frameworks update to the latest versions. We have that domain object, so this is exactly the same as the previous one. So if you're using synchronous access and you want to switch to asynchronous, your domain objects can remain the same. The repository changes from CRUD repository to reactive streams repository. I believe you also have to explicitly right now pass the dialect. If not, I think it doesn't pick up by default. So, okay, so there's two changes. It's not a big deal. How does the application look like now? Well, very similar to the other one. The only difference is, of course, we're now making use of reactive APIs, but also because I want to showcase this, don't do this in production, I'm blocking until I'm sure that the data is available in the database, has been written to the database, so later I can query it. If I were not to do this, there will be two different flux calls, and my application will just finish after doing subscription. I will never grab the values. So that's what I'm waiting. That's the only reason I'm doing this. Don't do this again, please. Believe me, don't do this in production. So once you query all these things, we wrap it in a flux, and then just use regular streams, just like that. So we run this application. Oh, by the way, of course, I should have shown you how we configure Micronaut to access the database. Well, here we are. Here's our database. The URL is very similar to what we saw before, username, password. And in the case of R2dbc, we do have to use a different URL. It took me a while to find this. Depending on your JDBC driver, and that's the same for MySQL, Postgres, and the others, the URL that you use for standard JDBC may not necessarily be the same one for R2dbc. So be sure to read the documentation of each one of those drivers to find out if you need to make changes to the URL or pass any additional arguments. All right, so here goes the application, and then just run it, okay? So what we expect again is two elements based in the database. When we query, we see two values, or two POJOs. And here we go. Continues to work. So far, so good. Finally, let's look at Quarkus. Who uses Quarkus here? I'm afraid I'm going to repeat myself when I say the way that you bootstrap a Quarkus project, browse to a web page, select your options, click on the download zip button, start and begin working. So that's how all these modern frameworks work. It's so easy. I also chose to go with Maven, for which there are many different ways to do this. I'm using the latest version of Quarkus right there. And I believe Quarkus does have, yes, they do have a managed version of the Oracle driver. But unfortunately for me, they're using OJDBC 8. But because I want to use Java 11, I had to explicitly configure OJDBC 11. And I did not configure UCP. I did not configure a connection pool because Quarkus will take care of that with Quarkus ARC or Quarkus ARC. So what I'm using in Quarkus is yet another domain object, very similar to what we saw before. A little bit of difference in the annotations, but the shape of the object is quite similar. And here's my application. What are we doing in the application? We're explicitly initializing the schema because I'm using the lowest level access API. I'm using JDBC. I'm not using, well, actually, I think I might be using Panache for this. but I set it up so that it doesn't automatically bootstrap the schema. You may have the choice to use it or not. So, because this object is, I don't know if it's actually based on an active record, but it's a rich object, it's just a rich domain object. It's not just getters and setters. It's inheriting from this thing called panache entity, which is an object that contains the save and the list, and in this case, persist methods. So you can think of this domain object as the mix of the actual object that can be persisted and the capabilities to persist those objects. In the past, we saw this as a to-do domain object and the CRUD repository. So for panache, we got the two things at the same location. Okay, so that's what we're seeing here. It's create two objects, persist, save it to the database, and then notice that again to do, now inherits that method find all, and this is a list. So this stream is actually a Java util, it's a Java stream. It's not a reactive stream. So I think in this case, I will drop down to the terminal. I have it here. Let's make it bigger. And let's go into the right demo. And yes, I know people know me that I say, don't do Maven clean install. I'm not going to do Maven clean install. I'm just going to do Maven clean build to be sure that we have the latest versions. And that thing that you see there, that GM is actually going to invoke Maven. It's not an alias, it's another command, which didn't work for whatever reason. Capital D, thank you very much. I love these pair programming sessions. So here we go. We just make it, I'm using clean to make sure that there's nothing under my sleeves because, hey, I have short sleeves. And when we do build, it actually invokes verify. So that ends having a jar. So yes, I can use Quarkus dev mode to just keep running this, but I'm just going to run it directly from the jar so that you know that there's nothing extra here. So Java, jar, from the target, Quarkus app, and then the runner, Quarkus run. And here we go. Bootstraps Quarkus, and I have the data. Boom. Finally, because I'm almost running out of time. The RX demo. Again, Maven, using the latest version. And the thing that is different here is we're using reactive panache, and we're using the reactive Oracle client. We're not using R2dbc because Quarkus does not support R2dbc. We go with Vertex. And with just like that, the additional bit that we have to see here, this is also something that's a little bit of a headache. Oh, actually, this one, why is it saying that it's using MySQL? This should be Oracle. I guess I changed the wrong version. Yeah, this should be other, and I believe this should be Oracle thin. This actually took me a while to find out what was the URL that I should be using. And of course, I think the username and password was system, and here should be admin01. There we go. Admin. Thank you very much. So that should be it. Done. So again, this took me a while to find. I didn't find it anywhere in documentation. It was lost in some GitHub repository where someone built an example. Well, now you know. Okay. So what can we do with this one? Here we have a to-do object. The difference with the previous example is, well, it has a bunch of annotations now for the columns, but the most important aspect is this one. It's a different base class. That's it. And there your application looks like this. It's making like standard RX application of Jersey application, whatever it is. And if you want to query one element, then you get a uni. What this thing is uni? This yet another reactive library called Almiray. What's the name? Mutiny. Yes. Thank you very much. Mutiny is the one that gives me these values. And I don't recall what is the name for the multiple values, but in this, I guess will be, I may hopefully multi if I see that this thing is uni. So get one of them, well, actually get all of them, get a single them, in this case, create all of them. And this Notice the return type. It's an observable thing. It's a reactive thing. And we're using just a standard Rx for this to work. So this means that this particular microservice, if I deploy it correctly, my client should be reactive. All right? So we're pretty much on time. So I have some resources for you. If you want to know how to use the Docker images from the Oracle XE images, they are on the first URL. Why there's a difference? There are official images, and there's this image from this guy. This is not a random guy. This is actually my boss. He created these Docker images, which are slimmer, they are faster, and they're smaller. So go with these ones, and then hopefully we'll eventually move it to the official place. There's a link for the Oracle DBC project, which happens to be open source, fully open source. I told you, Oracle does open source, not just Java or Oracle Linux. And there are lists to the other drivers and other APIs that we saw today as well. And I'm going to share the slides later as well if you want to see all the URLs. So everything that we saw today pretty much is open source. If you have not contributed to open source, let me tell you, it's quite simple. You find a problem with what we saw today, these frameworks, these libraries, these technologies, file a ticket. And that's it. That's everything that you have to do. You don't have to supply code. You don't have to supply test case. Just write a ticket. Let us know that something's not working properly. If you have the time and the passion, yeah, sure, supply a test case. But don't feel obliged to start writing code to get contributing with open source. So that's everything that I have for you today. So thank you very much for your time. And if you have any questions, I'll be very happy to take them. If not, well, you're very welcome and more than welcome to enjoy lunch. Any questions in the audience? There's a question over there. Yes?
I'm curious to know about the transactions, how you manage. If I have a mono and if I have a subscribe to a different subscriber, I would like to know how the transaction is maintained actually.
Okay, so the question is, if you have a mono and you have two reactive containers,
Yeah, I have two reactive containers.
and how will the transaction will work? It should work correctly as long as you're talking to the same database. But the moment that you're talking to two different data sets or two different things, that will be a, what would you call this? It's a cross data set transaction. It's kind of possible, but it's not as easy as I showed you in the source code. There's more things that you have to do, of course.
And the Spring transaction won't help, right? If I do an update and an insert in the same chain, and if I do a subscribe on those two monos, and if I use a transactional, the transaction will be...
So the thing is that if you have in the same stream two monos, one for insert, another update, if you first do if the insert happens first and then the update at the end of the chain, which value are you going to see? You should see the latest value, which will be the updated value.
Okay.
Because they're part of the same chain.
Okay. And even if I use two subscribers?
The thing will be the timing. If you use two different subscribers, and if they're running in different threads, one may run before the other. So you will perhaps need some sort of synchronization mechanism, or combine them into the same stream. Use a flat map or something similar.
Thanks.
Sure.
Any more questions?
All right. Well, thank you very much.
Thank
You've been
you.
a wonderful audience. Keep enjoying Jfokus.